Hey everyone, I am Dinesh, a B.Tech third year computer science student at SRM University AP, and welcome to my channel. Today I am excited to take you behind the scenes of one of my favorite projects, IncomeIQ, a smart income tracking and visualization tool that I have built. If you are someone who loves turning raw data into clear, meaningful insights, you are gonna enjoy this. So let's jump right in. Now I will share my code which I had built before. Yeah, this is my code. One second. To make to make the income insights more engaging and user friendly, I used a combination of powerful Python libraries. First, I imported Pandas library and NumPy for data handling and numerical operations. Then, for visualization, I used Matplotlib library and Seaborn to create static graphs with detailed styling. And to make it even more interactive, I integrated Plotly.express which lets user explore charts by hovering and zooming. A great way to understand income trends more deeply. Let me show you how I visualized the monthly income trends and category wise earnings. Hmm, This is the data load. To begin with, I loaded the dataset in a Pandas data framing using read underscore CSV. This dataset is stored in my Google Drive and contains income-related data including attributes like age, worker class, final weight, education, occupation, hours per week, and most importantly, the target class, target feature income. After loading the data, I use df.head of 10 to preview the first 10 rows. This gives me a quick glance at the structure of the dataset, helping me verifying that everything was loaded correctly and the columns are in the right place. And then I had explored the data using first I checked the shape of the dataset using df.shape, which tells me how many rows and columns it contains. These are the number of samples and this is the number of features in my dataset. Then I use df.d types to examine the data types of each column. This helps me identifying which features are numerical and which features are categorical, which is important for both visualization and preprocessing. The features which contains int are numerical and objects are categorical features. I also use a df.isNull.sum to check for any missing values. Handling missing data is crucial to avoid incorrect analysis or model performance issues. Next, I used df.nUnique gave me the number of unique values in each column. This is especially useful for spotting categorical features with low cardinality that may be perfect for grouping or visualization. Finally, I have used describe.t to get statistical insights like min, max, and standard deviation for all numerical features. This gives me a strong baseline understanding of how the data is distributed. And then, to better understand the distribution of categorical data, I used value counts on some key columns. Starting with worker class, I analyzed how income is spread across different employment types like private, self-employment, or government jobs. Then, using df.columns, I quickly reviewed all available columns in the dataset to plan which one is to visualize. For example, the occupation column helps me identifying which job roles are most common in the dataset. This is a valuable insight for income prediction and segmentation. I also used native country to see which countries dominate the dataset. As expected, most entries are from the United States. So here we can see United States are 43,832. It's very large comparing with another countries. Next, coming next. Next up, marital status and gender. Understanding these categories helps in visualizing social and demographic impacts on income. I also checked race to get a feel for the racial composition in the data. And finally, the most important column, as I said, this is the target column, income. This tells how many individuals fall under less than or equal to 50K dollars and greater than 50K income brackets. This exploration is important before we move to visualizations. So we can choose which columns provide the most meaningful patterns. Uh, Now, income and gender visualization. Now let's bring our exploration to life with some visualizations. Here, I have used Seaborn count plot to compare income distributions across genders. On the x-axis, on the x-axis, we have two income categories greater than or equal to 50K and greater than 50K and less than or equal to 50K. Here, I had used two for gender parameter. Let us break into it further by male and female. As we can see, a significantly higher number of males fall into the greater than or equal to 50K dollars income group compared to females. This kind of visualization helps highlight possible gender-based insight gaps, making it an insightful part of the income IQ dashboard. The, the palette cool warm gives a nice visualization contrast to distinguish the categories clearly. See how beautiful this graph is. And then education distribution. I use df of education.values underscore count to see how education levels are distributed across the dataset. This gives us a clear idea of which data levels are most common, like high schools, graduates, some college, or bachelor's degree holders. It is an important factor to consider when analyzing income patterns as education often plays a direct role in earning potentials. Here, this is the part where data cleaning has done. We have got some missing values in the data set. They are represented by question mark. We need to clean up so they don't skew our analysis. Skewing means our graph is like an Bellman curve. If one of the data is more concentrated on one part, the tail, the our graph will tilt somewhat, which shows the skewness of our graph, which misleads our data and our analysis. So for the work class column, I replaced the question mark with private since it is the most common category in the dataset. Similarly, for the occupation column, I replaced the question mark with professional specialty, a commonly occurring job role in the dataset. After replacing the missing values, I used df.head of 8 to preview the updated rows and ensure everything looks good. This part is very important that to move for the further steps. Going with feature engineering, for education category and marital status. Let's clean up and standardize some of the categorical columns. Starting with the education column, I grouped various education levels into border categories, broader categories to simplify the analysis. For instance, I combined all all the elementary and middle school levels like preschool, first to fourth, fifth to sixth, etc. in a single category called school. I also grouped high school grade into high school and combined bachelor's with undergrad and master's with grade and doctorates with DOC. These categories help condense the data while still preserving the importance distinctions. Moving to the marital status, I merged different forms of being married into a single married category and combined another relationship status like never married and divorced into not married or another. This kind of cleaning helps reduce complexity and ensures consistency in how we analyze these features. For income coding, finally, I tackled the income column, which originally had two categories greater than or equal to 50K and less than or equal to 50K and greater than or equal to 50K dollars. I transformed these categories into numerical values where less than or equal to $50K becomes 0 and greater than 50K becomes 1. This makes it easier for algorithms to process this data later on. I used df of income.infer objects copy equal to false to ensure that the column is properly interpreted as an integer rather than the object type. It means we have now converted the categorical data into numerical data, which will very useful for analyzing the data in a very simple manner. And then let's come to data preview. Now the data is cleaned up. Let's take another look at the ensure everything looks good. First, I use df.head to preview the first few rows of the data set and make sure everything is correctly formatted. Next, I have checked the marginal status and education value counts to see the distribution of each category. This helps me understanding the overall breakdown of people's marital status and educational levels before visualizing them. Next, coming to correlation and heat heat map. I had used correlation numerical only equal to true to calculate the correlations between all the numerical columns. This tells me how closely related features like hours worked per week or education level are to income. To visualize these correlations, I used a heat map with SNS.heatmap where the colors represent the strength of the correlation. This is a great way to quickly spot potential relations. For example, we can see that the income correlations positively with features like education level and hours worked. Here, this red color is highly correlated. Since age to age is highly correlated and it is 1, then as we know that the positive values are positively correlated and negative values are negatively correlated, we can see for every attribute to every attribute we can see how they are correlated with each other. And then I had used histograms and box plots. I use histograms for a high level overview of the distribution of various numerical features using df.hist. This gives a sense of how the data is spread out across features like age, hours, worked per week, and more. The histograms are laid out in a grid format, and see we can see here the grids. And I have set share x, e- share x equal to false to ensure each platform has its own access scale. No grid is to be shared with the another. So I had share x is false, making it easier to compare distributions individually. I also used a box plot. I will show it now. Box plot for categorical data to visualize the spread and potential outliers in the numerical features. Here are the outliers, these outliers make the analysis part very difficult. So we have visualized how these outliers are extreme values that could affect the analysis later. And then I also used pie chart and count plot also. For categorical data, I created a pie chart using Plotly to visualize the percentage of the people in different education categories based on the educational column. The T10 color palette, the T10 color palette adds a nice variety to the chart. Finally, I used a count plot to visualize the distribution of education levels across genders. The hue equal to gender parameter helps break it down further, and the seismic color palette gives a color contrast difference between the gender categories. These visualizations really help tell the story of data. We can start drawing insights how the factors like education, marital status, and gender influence income. The next steps would be to dive deeper into the analysis or even train a model to predict income based on these features. Here are the model buildings which we had done before that, preparing data and scaling. Now we have pre-processed our data. It's time to set up for machine learning. First, I separated the features X for the target value from the target variable Y, which is the income column. This allows us to train the models to predict income based on other factors. Next, I have applied label encoding. Here, I had used label encoding to transform categorical values into numerical form. This is necessary because machine learning models work with numbers, not strings. After that, I used standard scalar to normalize the features, which ensures that normal format numerical features are on a similar scale and helps the models perform better. Here are here some here I, we have trained some of the models. Now the data is ready. I split it into training and test sets using train test split with 70% of data for training and 30% for the test. This ensures the model is evaluated on unseen data, providing a more realistic picture of its performance. Let's start with the support vector machine model. I initiated it with SVC and it trained it on the training data. After training, we have predicted for the new data. It means for the testing data and finds accuracy. We got accuracy on training data is 0.858 and on testing data 0.51. Here, accuracy on training data is 0.858, which means we have trained on the data and we have predicted some of false, which is not that much good model, machine learning model for this data set. So we had used logistic regression, which is another popular algorithm for binary classification problems like this one. As only we have two categories that less than or equal to $50K or greater than $52K. So simply a model which categorize only into two classes is required for this data set. So linear logistic regression also classifies is a classifier model and tested it on the same split. Again, I have evaluated the accuracy to understand how well the model is predicting income levels. Here also the same problem we have raised that the accuracy on training data is 0.838, which is not at all good, I think. So we use random forest classifier, which is an ensemble learning method. It creates multiple decision trees and combines their results for more accurate prediction. After training the random forest model, I evaluated its accuracy on both training and testing data, and we already seen how different models might perform them varying levels of complexity and accuracy. So here the accuracy of the training data is 1. So we concluded that random forest classifier is the best model for our data set, and we fixed this model for further any need. For evaluation metrics, I had used a confusion matrix and classification report for the random forest model. This give us more detailed metrics like precision, recall, and FN score. I calculated precision and recall for the random forest model to understand how well the model is predicting both the positive and negative income classes. For instance, precision is the percentage of true positive out of all predicted positives, while recall is the percentage of true positives out of all actual positives. So here the recall for less than or equal to 50K, which is zero labeled class. This is the precision and recall. For the class label 1, this is the precision and the recall. Finally, once the analysis was done, I saved the cleaned and processed dataset in a new CSV file called IncomeIQ cleaned.csv. This file is now ready for any future analysis or modeling. So this is how we can predict income based on various demographic and personal factors using machine learning. With models like SVM, logistic regression, and random forest, we are able to gain insights into income predictions, and with further tweaks, we could optimize these models even further. Thanks for watching. Again, sorry, I need to share one thing that I have visualized this using Power BI. I'm super excited to walk you through the data visualization I created using Power BI, one of the most powerful business intelligence tool out here. So we can play with this Power BI website. If any wrong, it will play with us. So I have created five visualization. I have visualized using five visualization techniques. This first one is gender distribution in the dataset. Let's kick things off with gender representation. As we can see this in the pie chart, around 68% of the individuals are male, 68.32% are male, and 31.68% are female. This imbalance is important to consider while interpreting income and occupational trends. And coming to next, level distribution, income level distribution. Now let's look at the income distribution, the donut chart. Here tells us the about 76% of the individuals fall under income level 0, 76%. Income level 0, it means less than or equal to 50K, and 23.93% are having income class 1. Um, uh, that's a big gap, definitely something worth exploring deeper. And coming to third, occupation versus count. Next, we dive into occupation data using this coloring tree map. This is the coloring tree map. The most common job types include professional specialty, expensive managerial roles, and craft related trades. Interestingly, other service jobs also form a significant portion. This tells the dataset spans a wide range of professionals, adding richness to our analysis. And coming to age versus average hours per week, check out this line chart. It maps age against average weekly hours. We notice a steep rise in the work hours for early adulthood, streak rise, peaking around ages 40 to 50. Around that, it is gradually drops off, which makes sense as people transition toward retirement. So, for adults, it is rising, and for the moderate age, they are consistently working, and for old age, they are ready to retire since they can't work more and can't gain income. And the fifth one is gender versus income level. Here, a bar chart comparing gender to income level. Notice how males dominate the higher income category despite females making up a significant portion of the data. Their representation in the higher income bracelet is relatively low. This might point to potential gender income inequality or occupational segmentation. So, what does income IQ tells us overall? It's more than just numbers. It's a snapshot of workforce dynamics, income disparities, and demographic trends. Like projects like this helps us ask better questions about society, equity, and opportunity. If you found this breakdown helpful, don't forget to like, subscribe, and drop a comment if you want to see more data science projects walkthroughs. Until next time, keep exploring with data. Thank you.